In this demo, we will implement the proxy pattern. Let's start by adding a document class, our real subject. This consists of a few common properties you might expect from a document, like title, content, author ID, and last accessed. We also add a private file name field to it, so we know where to load it from. We don't want the document to be constructed without a file name having been passed through, so we add a constructor to convey that. The constructor expects a file name parameter, and we set the private underscore file name field to the pass-through parameter. Up next, we want to load the document from disk. For that, we want to add a load document method, which expects the file name. This effectively loads the document from disk. This is an expensive method. We fake that by adding a thread.sleep statement, so it takes a bit of time to execute this. Once the document has been loaded from disk between quotation marks, we fill out its properties. This method currently gets called from the constructor, so the expensive operation happens at the moment the document object is being constructed. We add one more method, something a client can call into, to display the document. In that, we write out some property values to the console output window. That makes this a bit easier to test. And with that, we've got our real subject, a document class. This doesn't have anything to do with a proxy yet, but what's coming up has. From this document class, we can now extract an interface. This will act as the subject from the proxy pattern structure. Both the real subject and the proxy must adhere to this. Let's say we want to put one method in it. Display document. Load document is private, so the only one we're going to put in it is display document. Seeing real subject must implement it, we do that. There we go. Let's give this a try already. Again, nothing proxy related in there at the moment, so we simply write out we're constructing the document, we load it, and we write out that the document has been constructed. After that, we display it. Let's add a read key statement and let's give this a try. We see that the expensive operation happens when the document is being constructed and not when it's first being used. In other words, not when it's being displayed. This may not be what you want, as this can make applications that require a lot of objects like this unnecessarily slow. Expensive operations like loading the files from disk may be executed without them being needed. Because if you don't display what's in the file, you don't really need it to be loaded from disk either. So it's better to offload this to the moment the document is first accessed. And that's where the virtual proxy comes into play. Let's add a new class. We'll name it Document Proxy. As the name implies, this is the proxy. It too must implement the iDocument interface. So let's do that. That means we need to implement a display document method on it. But let's first construct our document proxy. We do that by accepting a file name. But we don't construct the underlying real subject, our document, yet. So we don't call into the base constructor or anything like that. At this moment, the expensive operation has not been executed yet. We do need to implement this display document method. In this method, we need the underlying document, which may not have been constructed yet. So we add a private variable, _document, which will hold the document. It's nullable because the document hasn't been constructed yet after we leave the document proxy constructor. Constructing the document, that's what we do when a method on the document proxy is called. Display document. So it's here that we check whether the document is null. If it is, that's when we create it. Afterwards, we call display document on the document variable. This means that the first time we call into this method, the document is constructed and the expensive operation will run. After that, the document stored in the _document variable will be used. Let's give this a try. For that, we write a bit of extra code in our program file. We write out an empty line and then we use the document proxy to call display document on. As you notice, the way to interact with the document and the document proxy is transparent for the client. The client executes exactly the same statements. So for the client, interacting with one of both is the same. Let's give that a try. And there we go. The expensive operation is only executed when we actually need it to be. So the advantage here is that the cost of creation of the actual object can be deferred to when it actually needs to be used. The proxy thus lazily initializes the actual object that's interacted with. And this brings me to a small improvement we can make, something we also did when we implemented the singleton pattern. .NET includes support for lazy initialization out of the box via lazy of T. When correctly used, it ensures that the object of type T is only used when needed and not when initialized. So we can change our document proxy to support this. Instead of working on a document directly, we now want to work on a document that is of type lazy document. We also no longer need it to be nullable as the lazy object is constructed in the constructor of our proxy. We construct it by passing through an action which tells it how it should construct an instance of document. When the lazy of document object is newed up, construction of the actual document doesn't happen yet. Our display document method then becomes easier. We call into document.value.displayDocument. If it's the first time the value is accessed, and value is our document instance, the actual document object is created. Each time after that, the previously created instance will be used. Let's give this a try. We shouldn't have to change anything about our client code. And there we go. Still works as before, but this time in a thread-safe manner, because that is what lazy of T makes sure of. Let's look into the protection proxy and proxy chaining in the next demo. In this demo, we will learn how to chain proxies. Let's think about a new requirement. Our document should only be displayed when users have the viewer role. We could build this in the document itself or in the document proxy, but that would lay too many responsibilities on one class. Instead, we can load off this access right decision to a new proxy. So let me scroll down a bit, and let's add such a proxy. We'll name it Protected Document Proxy. This too should implement the iDocument interface, which makes this another proxy over the same type. We construct the protected document proxy by storing file name and user role, and by constructing a document proxy, which we also store. As we remember, the document proxy is our proxy from the previous demo, and it's this one that makes sure that the actual document will not be constructed at the moment document proxy is constructed. That also means that when the protected document proxy constructor is executed, the eventually underlying document isn't constructed yet. We are now effectively creating a chain of proxies. First, the protected document proxy, and after that, the document proxy. So, in display document, we check the role and throw an unauthorized exception if it's not viewer. Otherwise, we display the document. We surround this with a few console.writeLine statements so we can see exactly what happens when. And with that, we've chained our two proxies. Now let's test this. First, we new up a protected document proxy, passing through the file name and the role. We surround it with a few WriteLine statements so we can see what happens when. After the WriteLine statements, we call display document. Seeing the role is viewer, we should have access. And let's write something likewise, which will not give us access. Alright, let's build and run this. We hit an unauthorized access exception. That sounds like what we expect, because the last proxy chain we newed up shouldn't give us access. Anyway, let's continue so we can see what's been written out to the console output window. The first two paragraphs are from the previous demo, so we're interested in the third paragraph here. We see that it's the protected document proxy that's being constructed. And once we enter display document in the protected document proxy, the expensive action is executed, so that's the original proxy at work, and the content is written out. From this statement, we can nicely see the chain of proxies. And the next paragraph, as expected, tries the same but throws in an authorized exception, because we didn't pass through a role that would grant access. And with that, we've implemented proxy chaining. Let's continue by having a look at the use cases for the proxy pattern. The basic use case for this pattern is when you need to add some form of access control to an actual object, something that's more sophisticated than a simple object reference. The use cases come from the pattern variations. So let's have a look. For the remote proxy, the use case is providing a local representative for an object in a different network address space. Anytime you need to call into a remote API or service, this can be helpful. For virtual proxies, the main use case is creating expensive objects on demand. Smart proxies are useful for caching and locking scenarios, and protection proxies are useful when objects should have different access rules. A good real-life use case was the one we just implemented. Let's have a look at the pattern consequences. What this pattern does is introduce a small layer or wrapper between a client and the actual object. The consequences from that, again, vary depending on the proxy type. For a remote proxy, a consequence is that the proxy hides the fact that an object resides in a different network space. For a virtual proxy, a consequence is that an object can be created on demand. And for protection and smart proxies, a consequence is that additional housekeeping tasks can be executed whenever an object is accessed. As a general consequence, the pattern allows introducing new proxies without changing the client code. That's the open-closed principle from the solid principles at work. It also has some potential disadvantages. One is added complexity, because a new set of classes are introduced. Another one is a potential performance impact, because you're passing through one or more additional layers. Let's have a look at two related patterns. Two structural patterns are related to the proxy: the adapter and the decorator. The adapter provides a different interface to an object it adapts, while proxy provides the same interface. And decorators have similar implementations as proxies but serve a different purpose. As we remember, the decorator adds responsibilities to an object. The proxy, on the other hand, controls access to an object. Time for the module summary. We learned about the proxy pattern in this module. It's a very common one that's intended to provide a surrogate or placeholder for another object to control access to it. So, access control for whatever reason, and that doesn't need to be permission-based, is the main goal. The pattern comes in different flavors. The first variation is the remote proxy. The idea is that the client can communicate with the proxy, thus treating it as a local resource. The pattern hides the fact that the actual object exists in a different network space. The second variation is the virtual proxy. This one allows creating expensive objects on demand. You can look at it as a stand-in for an object that is expensive to create. Another variation is the smart proxy. Its purpose is to allow adding additional logic around the subject. And then there's the last variation, the protection proxy. This one is used to control access to an object. We implemented an example using a document class, and we learned how to chain proxies, which is a good way to stick to the single responsibility principle. Up next is the last structural pattern, the flyweight.